Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will discuss a structure of protein. Last class I have discussed amino acids and classification of amino acids. Now I am going to discuss a structure of protein. Proteins are the polymers of alpha amino acids and they are connected to each other by peptide bond or peptide linkage. Chemically, peptide linkage is an amide formed between COOH group and NH2 group. The reaction between two molecules, similar or different amino acids, proceeds the combination of amino group of one molecule with the carboxyl group of other. Here you have to understand the reaction between two molecules of similar or different amino acids proceeds through the combination of amino group of one molecule with the carboxylic group of other. Means here that NH2 group of amino acid, one amino acid, and COOH group of another amino acid, both will react and it will form water, means NH2 and COOH, that OH, both will react. And what will happen after the reaction? That from the COOH, OH, from the COOH, OH, and H from NH2, both will form water. It will go out as H2O. Then OH will go as OH minus and carbon will become positive. And from the NH2, H gone as H plus and N will become negative. Then positive carbon and negative N both will join and linkage will form. Okay. Then this linkage actually is called peptide bond or peptide linkage. Now two amino acid joined to each other and formed a linkage. They joined to each other by a bond or link, that is called peptide bond or peptide linkage. This I have told you about the how two molecules are joining to each other. Now this results in the elimination of water molecules and formation of a peptide bond. Then peptide bond means CONH, because that CO has joined with NH. Hence that peptide bond it is called CONH, bond between CO. C was having plus and N of NH was negative. Then this linkage is actually CONH. This is called peptide bond. Then this, I told you, this reaction results in the elimination of water molecule and formation of a peptide bond, that is the CONH. The product of the reaction is called peptide. What formed product? That is called dipeptide. Di means two. The product of the reaction is called a dipeptide because it is made up of two amino acids. For example, when carboxyl group of glycine combines with the amino group of alanine, we get dipeptide of glycyl alanine. Name will be accordingly. Again I am telling as example, when carboxyl group of glycine combines with amino group of alanine, we get a dipeptide. Its name is glycyl alanine. Glycyl alanine. Both names are included. Glycine and this amino group of alanine, then glycine and alanine. Then if you will mix, then you will get the name glycyl alanine, glycyl alanine. Now suppose, now I have talked about the two amino acids, different amino acids. Now just to consider, if a third amino acid combines to a dipeptide, the product is called a tripeptide. A tripeptide contains 3 amino acids linked by 2 peptide linkage. Similarly, when 4, 5 and 6 amino acids are linked, the respective products are known as tetrapeptide, pentapeptide or hexapeptide. Correct? Respectively. When the number of such amino acid is more than 10, then the product are called polypeptide. Again you listen. When more than 10, when the number of such amino acid is more than 10, then the products are called polypeptides. A polypeptides with more than 100 amino acid residues. Here you understand, a polypeptide with more than 100 amino acid residues having molecular mass higher than 10,000 unit, U, small u, 10,000 unit, is called a protein. Then now see how amino acid is linked to the protein. Amino acids form peptide. Correct? Dipeptide, tripeptide, tetrapeptide, pentapeptide, hexapeptide. When it is more than 10, then is called polypeptide. And a polypeptide with more than 100 amino acids, more than 100 amino acids residues having a molecular mass higher than 10,000 unit is called a protein. Means amino acid forms the peptides, means polypeptides, and if chain is long, means molecular mass higher than 10,000. If chain will be long, then obviously molecular mass will be more. Then if molecular mass is more than 10,000 unit, then it is called a protein. However, the distinction between polypeptide and a protein is not very sharp. Polypeptides with fewer amino acids are likely to be called protein if they ordinarily have a well-defined conformation of a protein, such as insulin. Insulin is also a protein which contains 51 amino acids. You remember, insulin is a protein and it contains 51 amino acids. Then here polypeptides, sometimes also called protein. Polypeptides with fewer amino acids, generally polypeptides will have less amino acids. Polypeptides with fewer amino acids are likely to be called a protein. What is the condition? If they ordinarily have a well-defined conformation of a protein, such as insulin, which contains 51 amino acids. Now, classification of proteins. Proteins can be classified into two types on the basis of their molecular shape. First type is fibrous protein. Fibrous, F-I-B-R-O-U-S, fibrous protein. And second is globular protein. Globular, G-L-O-B-U-L-A-R, globular proteins. Fibrous proteins, come to the fibrous proteins. When the polypeptide chains run parallel and are held together by hydrogen and disulfide bonds, then fiber-like structure is formed. You remember here, when two polypeptide chains, because it's a long chain, when the polypeptide chains run parallel and are held together by hydrogen or disulfide bonds, then fiber-like structure is formed. Such proteins are generally insoluble in water. It will not dissolve in water. Some common examples are keratin. Keratin, that is present in hair. In hair, keratin is present. In wool, W-O-O-L, wool, silk, means in hair, wool and silk, keratin is present. And you know, it is insoluble in water. Other example is myosin. Myosin present in muscles. Now come to the globular proteins. Second one, globular proteins. This structure results when the chains of polypeptides coil around to give a spherical shape. Name itself is there, globular. Globular means round. Then here, this structure results when the chains, not one or two chains, more, maybe more also. When the chains of polypeptides coil around, it means it can make a coil like that way. This structure results when the chains of polypeptides coil around to give a spherical shape. These are usually soluble in water. Example is insulin and albumins are the common example of globular proteins. Remember, insulin is the example of globular proteins. Albumins are also example of globular proteins. Structure and shape of proteins can be studied at 4 different levels. Correct? You remember here. Structure and shape. What are the shape of proteins? It can exist in different shape. Then structure and shape of proteins can be studied at 4 different levels. That is primary, secondary, tertiary and quaternary. Each level being more complex than the previous one. Means secondary is more complex than primary, tertiary is more complex than secondary, quaternary is more complex than tertiary. Correct? Tertiary means 4. Then this each level being more complex than the previous one. Now one by one I will discuss primary structure of proteins. Proteins may have one or more polypeptide chains. Okay, proteins may have, means primary structure of proteins that I am talking about. Proteins may have one or more polypeptide chains. Each polypeptide in a protein has amino acids linked with each other in a specific sequence and is thus sequence of amino acid. This sequence of amino acid that is said to be the primary structure of the protein. Any change in this primary structure, that is the sequence of amino acids, creates a different protein. Okay, then primary protein, I told you there is a sequence of amino acids. Many amino acids are there. I told you 20 are there, more than that it is there, but in our body 20 is sufficient. Okay, but it is more. Then sequence of amino acid, that is actually called a primary structure. But here linked, how all amino acid will be linked with each other in a specific sequence. And it is this sequence of amino acid that is said to be the primary structure of that protein. Any change in this primary structure, that is the sequence of the sequence of amino acids, creates a different protein. Correct? If change in primary structure I am talking about, that primary structure, if there is a change in the primary structure, then it will any change in this primary structure, that is the sequence of amino acids, create a different protein. Now come to the secondary structure of protein. The secondary structure of protein refers to the shape in which a long polypeptide chain can exist. Secondary structure of protein refers to the shape in which a long polypeptide chain can exist. They are found to exist in two different types of structure. Example, a helix, alpha helix, and second is beta pleated sheet structure. Okay, secondary can exist in two shape, alpha helix and second is beta pleated sheet structure. These structures arise due to the regular folding of backbone of the polypeptide chain due to hydrogen bonding. Means CO and NH groups are groups of the peptide. They will join to each other. Already I discussed polypeptide form CO and NH, correct, that have joined. Then these actually, because it is a long chain, these chains are, polypeptide chains are long, very long. Then these structure means secondary, these structure means alpha helix and beta pleated sheet structure. These structure arise due to the regular folding, it will fold, correct. These structure arise due to the regular folding of the backbone of the polypeptide chain, Why it will fold? Why it will fold? Then this is due to the hydrogen bonding. Then where hydrogen bonding will take place? Then in CO, oxygen is there. Oxygen is electronegative. And NH group, H is positive. H is positive. Then they will make a, then chain will come close, then they will attract to each other, electronegative and electropositive atom. Electronegative atom, that is oxygen, and electropositive hydrogen, both will come close and they will make a weak bond. That is called hydrogen bond. That's why that it will link, that chain will link to each other by hydrogen bonding. When it, then it will form a, you can say alpha helix structure or beta pleated sheet structure. Means there a special bonding is hydrogen bonding. Okay. Now come to the alpha helix and beta helix, little details. But bonding will be there, hydrogen bonding will be there. Alpha helix is one of the most common ways in which a polypeptide chain forms all possible hydrogen bonds. Correct? Alpha helix is one of the most common ways in which a polypeptide chain forms all possible hydrogen bonds by twisting into a right-handed screw. That is called helix. A screw you have seen, then how cutting is there? It is always it will be rounding like that. Correct? Means you can understand a stair. A stair, railing will be there, two railing will be there, left and right. You are holding and going up. Suppose that a stair is moving. Suppose you have to go to the third floor. Then it will turn. Then both railing will turn. Correct? Then in a screw also, what you have seen the structure cutting, that is that type of a structure I am talking. That is called a helix. Then here alpha helix is one of the most common ways in which a polypeptide chain forms all possible hydrogen bonds by twisting into a right-handed screw, that is called helix, with the NH group of each amino acid results in hydrogen bonding. Okay. Here twisting into right-handed screw means helix. And how they are forming this helix structure? Then this is due to the you can say bonding. NH group will be there. NH group of each amino acid residue, you can tell. NH group of each amino acid residue hydrogen bonded to CO. In NH, H is there. Then NH group of each amino acid residue hydrogen, NH hydrogen bonded to the CO of an adjacent turn. Means every time N and O will come, NH and O will come in front of each other. Correct? If it will turn, means helix form, then CO and NH both will come little closer. Then O and H will attract to each other. And then many this hydrogen bond will form. Okay. With NH is there and CO, O is there. Then between O and H bond will be formed, and it will form a helix. Okay, I will helix, just like you understand that best example is that railing only, a stair. Suppose you are going 3/4 floor, then how see that both railing, left side, right side railing are turning, correct? Just like two ribbons you are turning, and also think that they both are in parallel. Both are in parallel, like that way it will turn, it will go up. Then that type of structure, that is called alpha helix. Now come to the beta structure, beta pleated sheet structure. Then in beta structure, all peptide chains are stretched out to nearly maximum extension and then laid side by side, which are held together by intermolecular hydrogen bonds. The structure resembles the pleated folds of drapery, and therefore it is known as beta pleated sheet. Here that structure is different from the helix. This is actually secondary only. In secondary two are there, alpha and beta pleated structure. Then here that they arrange this chains will be arranged in such a way that there will be extension externally. It will make like that, and there also here will be not like that a screw or this screw or alpha helix, like two sides railing, two railings are there, that they are maintaining, that they are moving. Here it is not like that. Here they are also there, chains are there, but extension is there, and that extension is due to the hydrogen bonding only, intermolecular hydrogen bonding. In beta structure, all peptide chains are stretched out, not inside, outside. Chains are stretched out. Why it is stretched out? And it will be stretched out to nearly maximum extension and then laid side by side bond they will make, maximum extension, and then laid side by side, which are held together by intermolecular hydrogen bonds. The structures resembles the pleated folds of drapery, and therefore is known as beta pleated sheet. Okay, I will send this type of diagram. Now third come to the tertiary, means in beta plated also had intermolecular hydrogen bonding is there, but externally there will be a stretch, maximum stretch will be there. Okay, and it will take a form of a sheet like a structure it will form. Now come to the tertiary structure of protein. Then all are globular form. You remember, tertiary structure of proteins. The tertiary structure of proteins represents overall folding. Here also folding will be there. The tertiary structure of proteins represent overall folding of the polypeptide chains. That is, further folding of the secondary structure. It gives rise to two major molecular shape. First shape is fibrous and second is globular. Means in tertiary structure both shape will be present. In tertiary structure, fibrous shape and globular both will be present. The main forces which stabilizes the secondary and tertiary structure of proteins are hydrogen bonds and disulfide linkage. Other also is there. Here van der Waals forces and electrostatic forces of attraction also works. Means here total four type of big forces are working, acting. That is you have seen in the primary and secondary only hydrogen bond was there. Only hydrogen bonding was there. But here what you will see, along with the hydrogen bonding, disulfide linkage will be also there. Means sulfur in the middle of two chains, sulfur will come, S2, SS, and this S is electronegative sulfur, that can also join with H plus, just like oxygen. Correct? Then here disulfide linkage will be also there. Hydrogen along with the hydrogen bonding, means first bond will be hydrogen bond or hydrogen bonding. Second will be disulfide linkage or bond. And third will be van der Waals forces, very weak forces. And also one more forces will be there, that is the electrostatic forces due to the weak charge, due to the positive negative weak charge. Okay. Then four type of forces are working. Bond is also force, attractive force. Correct? The hydrogen bond is also intermolecular force, or also can tell bonding. Bond means little more force. Hydrogen bonding, I told you, and disulfide linkage, that is also a bond only. And then two bond you can tell, and two weak forces, that is the van der Waals forces and electrostatic forces of attraction. Then here actually this tertiary has a structure is more complicated than secondary. Now come to the fourth one, quaternary structure of protein. Then some of the proteins are composed of two or more polypeptide chains, referred to as subunits. The spatial arrangement of these subunits with respect to each other is known as quaternary structure. You remember that here in quaternary structure of proteins, some proteins are composed of two or more polypeptide chains, that is called subunits. The spatial arrangement of these subunits with respect to each other is known as quaternary structure. Correct? Then this is again further more complicated than tertiary structure. You can see that diagram. I will send that diagram, then you can understand. Then here you will see in tertiary, means primary structure will be, you can say, just like a straight chain, primary. Okay, a straight line chain like that. That is the primary. Secondary structure will be, just I told you, given the example, a strand structure. Okay, a strand structure. What I told you, railing of stairs. Correct? Left side, right side railings are there, and it is turning, but always they will maintain the distance in a parallel way. That is called a strand structure, double strand. Then this is actually secondary. It is not very complicated, only that it is turning. Two rope like that, rope you know that rope, how rope is forming. Then if two rope, how you can say, two thin thread you have taken, suppose two threads, and both you are making joining to each other, they are making round like that. Correct? Both. Correct? Then that type of a structure is here, double strand structure. Now tertiary structure. If you see this structure, then here you will find that little difference is there in tertiary and secondary and tertiary. Here also a structure will be like that, a strand only, but there just like length, breadth, height. It is 3-dimensional. Name itself is a tertiary. Then here length will be there, breadth will be there, and upside also it will be there. Height like that. Correct? It is also, it will turn, but it will also turn. Then height will be also there, upside also it will go. Correct? It will come down, again it will go little up, again it will come down, again it will go up. Correct? Just like what you are making a wave or W type, W. It will come, suppose double strand is coming, again coming down, again going up, again coming down, again going up, just like a W, like that type of a structure. Okay, turning side it is making like W structure. Just for example I am telling you, that is the tertiary. And quaternary, that is related to 4 layer will be there. Then one layer is more than tertiary. Then quaternary structure is now more complicated than tertiary structure. Means here you will find a secondary type of structure, tertiary type of structure, and now height and other things I told you, it will go more up, and again it can make link with the chain. It will go up, means inside only, suppose a chain was there. Correct? Just like from down to up it went. Down to up it went, again came down, again it went up, and it is joined somewhere with the chain. Okay, then everywhere wherever a scope will be there, they will make bonds. Like I told you, hydrogen bonding sometimes disulfide linkage, sometimes electrostatic force, sometimes van der Waals force. All four you can say forces to bond in the sense of bond. You can tell hydrogen bond, disulfide bond, or linkage, alpha linkage. Hydrogen bond you can tell, disulfide linkage. Third, that is the two forces, van der Waals forces, and fourth one is electrostatic. Then all forces you will find here. Okay. In quaternary. In quaternary you will find all these forces. In this also, tertiary also, all these forces you will find. And quaternary, here that is because proteins are composed of 2 or more polypeptides chains, and that is called actually subunits. Then arrangement different will be there. All forces will work here. The spatial arrangement of these subunits with respect to each other is known as quaternary structure. Here also all 4 types of forces will work, means 2 bond and 2 forces. And this diagram, by diagram you can understand very easily. And here I want to tell you that primary, secondary, tertiary and quaternary structure of all these structure you will find in hemoglobin, means blood. All these 4 structure you will find in hemoglobin. Question is asked. Primary also, secondary also, tertiary also, and quaternary structure also. All 4 structures are found in hemoglobin. Okay. Then hemoglobin structure, now because all type of structures are there, then actually it is just like what you can say, that now just like linear structure primary, I told you that only is a turning, sometimes simple turning, sometimes complicated, sometimes more complicated, correct, because many polypeptides are there, chains are there, then they are turning here and there, and they are making linkage. How they will make link? Then only due to the 4 region only they can link to each other, but their situation will be different. There how they are moving, how they are arranged, that is different. If it is a straight way, then you can tell primary. If it is only double strand, then you can tell there is a secondary. If it is complicated, means height is also there, something during the joining, and that is a tertiary. Again you can say again more complicated is there, then that you can tell quaternary. Then for the quaternary, here you should understand nitrogen has lone pair of electron. Then there also this lone pair electron can be given. This lone pair of electron can give to the others. Then there also bond formation is possible. That's why quaternary is due to this lone pair of electron. It will also make a bond. Then I told you that in hemoglobin all these 4 type of structure is present. Now I am going to tell, I want to discuss now denaturation of proteins. Denaturation of proteins. Now you know that in protein hydrogen bonding is there, correct? And this disulfide linkage is there. Third one I told you that van der Waals forces is there. Fourth one is, which forces are there? Ionic, electrostatic forces are there. Then now here in denaturation means that due to these forces proteins are arranged in a particular fashion. Due to these forces they got a special type of structure. Now suppose if this bond will break, or even that peptide linkage also you can tell, suppose that also breaks, if you will supply the heat, then what will happen? Now they will lose the character of protein, all chain will break, all chain which was bound through hydrogen bonding, disulfide linkage, this electrostatic and this van der Waals forces, all will break, then they will lose the character of protein. Then that is actually called here denaturation. Okay, I am telling you details. Okay, protein found in a biological system with a unique 3-dimensional structure, means length, breadth, height. Correct? Proteins found in biological system with a unique 3-dimensional structure and biological activity is called native protein, and its biological activity is called native protein. When a protein in a native form is subjected to a physical change, like a change in temperature or chemical change, like a change in pH, the hydrogen bonds are disturbed. Due to this, globules unfold. It was folded, then now globules unfold and helix gets uncoiled. Helix get uncoiled and proteins loses its biological activity. This is called denaturation of protein. During denaturation, secondary and tertiary structures are destroyed, but primary structures remains intact. It will not disturb. Secondary, tertiary, that will disturb. that bond breaks. During denaturation, secondary and tertiary structures are destroyed, but primary structure is strong actually, remains intact. This question is asked. The coagulation of egg. You might have seen egg, if you will, before boiling, in egg liquid will be there. Correct? Liquid will be there, yellow liquid inside. But if you will boil, then what will happen? That is actually what a liquid is there, yellow liquid, that is a protein, full of protein. Then there all different type R bonds are there, all four, what I told you. But when we will heat, then secondary and tertiary structure will destroy. Correct? The coagulation of egg, the coagulation of egg with egg white on boiling. Now we have seen that inside also and white color, you know, egg white. Correct? That is also protein. Then the coagulation of egg white on boiling is a common example of denaturation. Egg when you are boiling, then before boiling you see inside liquid will be there, many liquids. Correct? Liquid will be there, you can shake, you can hear the voice also. But after boiling it becomes solid. Then coagulation of egg white on boiling is a common example of denaturation. Another example is curdling of milk. Milk becomes curd, converts to curd. Milk, you can see, milk is fully liquid, but curd is becoming solid. And this is another example. Another example is curding of milk, which is caused due to the formation of lactic acid by the bacteria present in milk. Correct? This is actually formation of lactic acid by the bacteria present in milk. Here also that bond breaks, secondary and tertiary structure, protein secondary and tertiary structures breaks and it becomes solid. It is not like this milk, it becomes somewhat solid. This is the again second example, means curding of milk is the second example of denaturation. And first example, that is the coagulation of egg white on boiling. Correct? Two example I have told you. Now I want to give idea about enzymes. Okay, enzymes. What is the enzyme actually? That I want to tell you. See, life is possible due to the coordination of various chemical reactions in living organism. An example is the digestion of food, absorption of appropriate molecules, and ultimately production of energy. This process involves a sequence of reactions, and all these reactions occur in the body under very mild conditions. This occurs with the help of certain biocatalysts. Outside catalyst we are telling simple catalyst, but if catalyst inside the body is called biocatalyst, then these reactions takes place in the presence of biocatalyst, and this biocatalyst is called enzyme. And what is enzyme? Enzyme is a biocatalyst. Almost all the enzymes are globular protein. Now you can see enzymes are globular proteins. And what is a protein? That is the sequence of peptide linkage, big peptide link. And what is the peptide link? That is the sequence of amino acid. Then see, everywhere amino acid is there. Due to the amino acid, peptide linkage formed and long chain formed. and that is called polypeptide, and only in polypeptide condition is there. Up to 100 units, that is called polypeptides, and more than that, if 10,000 and more molecular mass is there of this polypeptide, then that amino acid is forming polypeptide is forming protein, and this protein is called here enzyme. If protein function as a catalyst, this is the condition. If a protein function as a catalyst, then it is called biocatalyst, or I can tell enzyme. Almost all the enzymes are globular proteins. Enzymes are very specific for a particular reaction. In a body, for each reaction, one catalyst is required. Biocatalyst, that is called enzyme. You remember, for every reaction, one separate catalyst will be required, not common. Almost all the enzymes are globular protein. Enzymes are very specific for a particular reactions and for a particular substrate. They are generally named after the compound or class of compounds upon which they work. Means substrate where they are where reaction is going on. Means A and B will react. That is A and B substrate or A and B compound. Then according to that substrate, its name is given. Catalyst name will be given according to the substrate or compound where it is working. Correct? They are generally named after the compounds or class of compounds upon which they work. For example, the enzyme that catalyzed hydrolysis of maltose into glucose. Suppose now maltose is converting to glucose, then that time catalyst will be known as maltase. ASE in the end, ASE will come, maltase. Then now because it is working on maltose, that's why name is given maltase. ASE, that is a sign of enzyme. Then maltose is C12H22O11, just like a sucrose. Sucrose, it is also same way, but only different is that sucrose will give on hydrolysis glucose and fructose, one molecule glucose, one molecule of fructose, but maltase will give directly 2 molecules of glucose. It will give 2 molecules of glucose. Then here this will happen only in presence of maltase. Okay. Sometimes enzymes are also named after the reaction when they are used. For example, the enzyme which catalyze the oxidation of one substrate with simultaneous reduction of another substrate are named as oxidoreductase. Sometimes by reaction also, in the name of reaction also name is given, but it is less. Example is oxidation reduction reaction, suppose it is going, and for this oxidation reduction reaction catalyst is required, enzyme is required, then that will be called oxidoreductase. ASE will be there in the end, oxidoreductase. This is the name of enzyme. The ending of the name of an enzyme is ASE, age. Correct? Then this I have given idea about enzyme. Enzyme is also protein, globular protein. Then see importance of amino acid. Due to the amino acid, peptide is formed, and again peptide only long chain peptide means very high molecular mass. That is called protein, and that protein how and where what is working, accordingly name is given. Correct? If it is functioning as a catalyst, then this is called biocatalyst and popularly known as enzyme. Then now I am stopping only here. And one more thing I want to tell you before finishing this enzyme. Mechanism of enzyme already I have discussed. Same mechanism there, what I have discussed in physical chemistry, same type of mechanism is there. Enzymes are needed only in a small quantities, not in more big quantity. Enzymes are needed only in a small quantities for the progress of reaction, similar to the action of chemical catalyst. Same way, enzymes are said to reduce the magnitude of activation energy. You already have discussed. Activation energy generally without catalyst, a reactant has to cross the energy barrier, high energy barrier, to go up high energy, then it will transition state is there, that state will reach, then it will, their bond will, old bond will break, new bond will form, and after a new bond will form, then their energy will be less, then it will come down. Sometimes it will be not go very down, it will be, you can say, above what was the you can say reactant energy, then sometimes it will come below the reactant energy. Suppose A plus B was there, and sometimes it will come below the A plus B, means below the energy of A plus B, correct? And sometimes after this top I am talking about, it will come down below the energy of A plus B, correct? Sometimes it will remain only up above the A plus B, correct? Then already you know that because it went to the top highest energy, and then it is coming down. Suppose it is a upside only, means above the reactant energy, then what will happen? There, because it is reactant energy was less, and now it is product has energy that is more. Product has more energy because then it is up. Then it means in this reaction heat will be required, because product required more energy than reactant. Then you have to heat it, correct? And when it is coming down after the product, after the reaction, product is coming down below the reactant energy, then below the reactant, it means it required very less energy, correct? It requires very less energy. Then here in this reaction, excess energy will go outside, correct? Exothermic reaction, because here energy requirement is less, correct? And during this reaction energy will be released, that is called exothermic. If product has less energy than reactant. And endothermic means you have to supply the heat, because product energy is more than reactant energy. Then here also catalyst is required, then catalyst decreases the activation energy, top become less. Now it was required more energy, but in the presence of catalyst, now it will require less energy. That is, energy will be less, reduced, become less. Then that is the purpose of catalyst or enzyme. It will reduce the activation energy. Activation energy means here that how much energy required to cross the energy barrier, correct? Just like 100 rupees is in your pocket and 500 rupees you want to purchase something, then 400 is requirement. That 400 is activation energy. Then catalyst will reduce this 400. They may brought to the 300, 200. Just rupees I am telling you, you can tell calories, means energy unit you can tell. Then here I told you enzymes are needed only in a small quantities for the progress of reaction, similar to the action of chemical catalyst. Enzymes are said to reduce the magnitude of activation energy, For example, activation energy for acid hydrolysis of sucrose is 6.22 kilojoule per mole, while the activation energy is only 2.15 kilojoule per mole when hydrolyzed by the enzyme sucrase. Correct? Same reaction I am talking about. Now, that is the activation energy for acid hydrolysis of sucrose. Acid hydrolysis of sucrose is required 6.22 kilojoule per mole, while the activation energy is only 2.15 less, 2.15 kilojoule per mole when hydrolyzed in the presence of enzyme called sucrase, ASE. From the sucrose it became sucrase, ASE. Mechanism for the enzyme action already I have discussed. Okay, now next class I will discuss vitamins. Thank you.